do this question, find the duplicate number. Okay, so what is in this question? They're given an array. It will contain number from 1 to n inclusive, and the number range, okay, from 1 to n, and it contains it will contain n plus 1 integer. Okay, it will contain n plus 1 integer. Okay, so we have to find the repeated number. Let's say for this 2 is repeating, 2 will be the answer. For this 3 is repeating, 3 will be the answer. And same number can be repeat more than once. Okay, and only one number will repeat itself. Okay, so first thing what we can do, we can uh, what we can do, we can sort it. Okay, we will sort it, and we will check the next element if it is, or we can start from first index, and we will check the is it equals to previous. Is it, if it is equal, then we will then it's mean that it is repeating, and we will return that number. Okay, so the time complexity in that case will be big of n log n, and the space complexity will be big of 1. So can we optimize it? uh, okay, so here they are saying that we cannot change. Let's say if we don't have to change the number, we don't have to modify it, then what we can do, so as we know that the number will be in range of 1 to n. Okay, so we will 1 to n, so we can decide, uh, we can search the number. Okay, and we can search the, and we will decide that which number to be searched. Let's say in this case, so we can use binary search here. So we can see here n equals to what, n equals to 5. Yeah, n equals to 5. Sorry, n equals to 4 here. Let's say it can contain number from 1 to n. It can contain n plus 1 integers. So yeah, so here the size, let's say, let's consider here size equals to what, size here is 5. So n plus 1 integer, so here n is equals to 4. Okay, it can contain number from, it will contain number from 1 to 4, both are inclusive. It will contain number from 1 to 4. So what we can do, let's say here we will start searching. Let's say start equals to 1 and n equals to 4. So what will be the mid will be 1 plus, let's say start plus 8 minus start by 2. Okay, so we will search that here. Let's say mid is 3 by 2. Okay, mid is 2. So we will search that number of 2 present in whole array. Okay, number of element which is less than or equals to 2 present in whole array. If it is equals to that number, it's mean that if it is greater than or equals to greater than that number, it's okay. If it is less than or equals to that number, or let not less than, if it is equals to that number, it's mean that there is no repeating element before this. Okay, and then we will, it's mean that we will change our start pointer to mid plus 1. Else, in else case, the end pointer will be what? The end pointer will be, we will move end pointer to mid minus 1, because if the number of number which is less than equals to that mid is greater than mid, then there is some might, there will be some number which is repeating its. So this way we can do. So the here the time complexity will be of n log n. Okay, and a space complexity will be v of 1 constant space. So and this is one solution. So now we can optimize it as well. What we can do now, while traversing in this array, okay, we will make the element which is we will make this element we will make the element present at this index minus 1, this element minus 1 to negative. Okay, and if it is, let's say if it is already negative, it's mean that we visited that index earlier, and it's mean that that index is repeating, and this is the repeated number, and the index plus 1 will be the repeated number. So and later what we can do, we will make it absolute, like we will make a non-negative letter, we will make every element positive, so that we are partially modifying that this number. Okay, so but we don't have to modify it, as you are telling that we don't need to modify. So but in this case the time complexity will be v of n, because we are iterating only once, and the v of 2n you can say, because we are iterating linearly, and the space complexity will be v of 1. Okay, now the fourth solution is that uh, we can use two pointer technique. Okay, slow and fast. We can treat it as a linked list. Okay, so one is linked, this is linked with, one is linked with index of this. Okay, three is linked with this two is linked with four is linked with 2. So this way we are, if it is repeating, so in mid, if and in whole it will make a cycle. Okay, so we can find the cycle, it is present or not. Obviously it will present, and then later we will decide the starting point of the cycle. Okay, so int slow equals to nums of 0 and fast equals to nums of 0 as well. Do slow equals to nums of I fast, not slow and fast equals to nums of fast. Slow not equals to fast. If it is this the case, then slow equals to make it to first element, and to nums of slow and fast equals to nums of fast and return slow. So here the time complexity will be O of n and the space complexity will be O of 1 as well, O of n and O of, yeah, that's all. Submit it. Accepted. That's all. Thank you.